This is Group 25's project and application proposal for CSE 412. We are proposing a web-based application that will function as a flight booking simulator. The application we are building will be a flight booking simulation application. The purpose of this application is to provide users with the ability to reserve and purchase flight tickets for their trip from a set database. While building the database for our application, our group identified 6 major entities that will be required to properly build a database and future working application. Our database will need an airport entity to hold the basic information about where flights are landing or taking off from, an airline entity to claim certain flights under their operation, a flight entity to represent the information required for the user to purchase ticket and receive flight information, a schedule entity to hold the takeoff and landing information for a flight, a ticket entity that contains the detailed information about the user's flight and select information about the user, and lastly, a person entity that represents the user and their information that is required to correctly book a flight. So this is our ER diagram for the application's database. As there are a lot of parts to it, we will be breaking down the diagram based on the entities previously mentioned and describing their relationships with neighboring and connected entities. The application we are proposing surrounds itself around a flight object. The flight object will be the main object users interact with when purchasing tickets and receiving flight information regarding their flight. The flight entity consists of a list of attributes for uniqueness from other entities, including the flight's duration, whether or not the flight is domestic, the airline name, passenger count, capacity, and flight number. As shown in our ER diagram, the flight entity has a relationship with 5 other objects, each of which we will examine in the following slides. Each flight has to be operated by some airline. Flights have a one-to-many relationship with an airline. This ensures that an airline entity can host or operate several flights at a time, but a flight can be associated with only one airline. The attributes that identify an airline are its arrival terminal, the airport ID, and the airline name. Additionally, an airline entity has a many-many relationship with airport entities. This relationship creates an environment where an airport can have multiple airlines operating their flights in and out of the airport, and an airline can have multiple operations running within one airport. The airport entity has 4 attributes, those of which being the airport ID number, the airport's location, the airport's contact, and name. As previously mentioned, the airport and airline entities share a many-to-many relationship to allow for several airlines to interact with several airports and vice versa. In addition to this relationship, the airport object has a one-to-many provider relationship to the ticket object. This design achieves the ability for an airport to distribute many tickets to any number of passengers, but a ticket can only be acquired from one airport. Next, we have the schedule entity. Every flight follows a schedule in order to ensure that the passengers get to their respective destinations on time. To ensure that a flight has only one schedule to follow and that each schedule belongs to a flight, the flight and schedule entities will sustain a one-to-one relationship. This schedule will have the country the flight will be traveling to, the airport of the flight, the arrival time and the departure time of the flight, the arrival date of the flight, and the city the flight will travel to. To show the relationship in a simpler way, the ER diagram was stunted to display the many-to-many relationship between the schedule and airport entities. A schedule must connect to one or more airports to fully represent the arrival and departure information that coincides with any flight. Returning to the ticket entity that was previously mentioned, tickets share a one-to-many relationship with the flight entity. The attributes associated with the ticket entity are personal ID or the person entity's ID number, the ticket price, the order number for the ticket, and the flight number that the ticket is assigned to. In order for someone to be on a flight, they must have a ticket assigned to that flight, which is acquired through a ticket purchased by the user or the person entity. So with this brings us to the final entity in our ER diagram. The person entity represents the user and important information associated with them that is needed to book a flight. This information consists of the person's first name, last name, phone number, birthday, and PID or personal ID number, and the person's citizenship. The person entity must have a many-to-one relationship with the ticket entity through the purchase of a ticket and ultimately the booking of a flight. Now that we have analyzed our ER diagram in full, we will move on to our implementation plans for this application. We will be using Angular to develop the front end of our application. We chose Angular as our team has experience using Angular to develop web applications and for its ease of use with Node. For our backend, we will be using Node Express to connect our front-end user site to our database that will be built using PostgreSQL. The Angular frontend will be used to capture user input for searches using HTTP requests to communicate with our Node Express backend. From there, Node will send the user's queries to the database system using the SQLize ORM Node package. Once the data is received from the query, it will be sent back to the backend and displayed on the front end in a user-friendly format. And with that, we conclude our presentation. Thank you for watching our proposal video.